So, you're an engineer just getting your career started, and you're planning for a world that honestly might not even exist in 10 years. The tools you're learning right now, they could be totally obsolete before you even hit a senior level. The big question is, how do you build a career that's actually going to last? Let's get into it. I mean, this is the question for your entire career, right? The frameworks, the languages you're learning, they could be ancient history in a decade. So, what's the game plan? How do you put in the work today to make sure that 30 years from now, you're not just hanging on, but you're actually leading the charge? Well, the answer really boils down to two things. You've got to focus on the future frontiers. That's the what you're working on. And at the same time, you have to master the timeless skills. That's the how you do the work. A career that lasts is built right where those two things meet. All right, let's start with the what. We're going to explore 7 of these massive growth areas, the fields where the demand for engineers is just going to explode over the next generation. First up, we've got two frontiers that are basically two sides of the same coin: real world AI and autonomous robotics. Look, this isn't about building slightly better algorithms in a sterile lab. The real challenge, and where the massive opportunity is taking that intelligence and plugging it into the physical world to solve really complex, messy, human-sized problems. The scale of this it's just mind-boggling. We're talking about AI-powered robots helping out in elder care facilities, autonomous drones that are completely changing farming and disaster response, and smart infrastructure that's optimizing our power grids second by second. This is all about weaving intelligence into the very fabric of our world. And here's the absolute key takeaway. In the future, your value isn't going to come from just creating a new AI model from scratch. It's going to come from your ability to adapt, to integrate, and to apply these incredible tools to solve the complicated problems that actually exist out there in the real world. Okay, our next pair of frontiers are both about rebuilding our world. On the one hand, you've got the clean energy revolution, completely redesigning our physical infrastructure. And on the other hand, we're building a digital replica of that world, a virtual model of, well, everything that we can test and optimize. And the projects coming down the pipeline are just huge. We're talking about engineering next gen batteries, much safer nuclear reactors, and smart grids that can handle renewables. And at the exact same time, we're building what are called digital twins. These are complete virtual copies of entire cities. Imagine being able to design a city with zero traffic, or know when a bridge needs repairs before it fails. That's what we're talking about. Now we're shifting gears to frontiers that are on a whole other level. We're going from programming computers to literally programming biology itself. And then, at the other extreme, we're turning the vacuum of space into an industrial platform. Just think about this for a second. With synthetic biology, we're editing the source code of life. AI is designing new medicines in a matter of months, not decades. And at the same time, private companies are building reusable rockets, they're planning moon bases, and they're seriously figuring out how to mine asteroids. This isn't science fiction anymore. These are the engineering problems of today. And of course, with all this powerful new tech comes massive new vulnerabilities. And that brings us to our next frontier: AI-era cybersecurity. In a world where AI can launch attacks at an exponential rate, the engineers who build our defenses are going to be absolutely invaluable. This is the shield that protects everything else we've just talked about. So, we've looked at all these exciting frontiers. That's the what. But now let's talk about the second, and you could argue, even more important part of the map: the how. These are the skills that will be the bedrock of your career, no matter which one of those frontiers you decide to jump into. You should think of these 5 skills as your essential toolkit. It seriously doesn't matter if you end up building moon bases or programming cells. A rock-solid foundation in physics and math, being fluent in software, really getting systems design, being able to communicate technical ideas clearly, and having a strong ethical compass, these are the non-negotiables. Let's just pause on systems engineering for a second, because it's not so much a specific technology as it is a way of thinking. It's the skill of looking at a ridiculously complex problem, like building a smart city, breaking it down into pieces you can actually solve, and then putting them all back together into something that works beautifully. As the world gets more and more complex, this skill becomes priceless. Okay, so this all sounds great in theory, but how do you actually start building this future, like right now, as a student? Let's make this super practical. Here's an action plan you can literally start on today. First things first, double down on your math and physics fundamentals. They're the language of how the universe works. Next, you have to learn to code. Python is a fantastic place to start. Then, don't just learn about AI, learn to use it as a powerful tool in your own projects. And finally, you've got to get your hands dirty. Join a research lab, get in the habit of reading the latest technical papers, and go get an internship to see what real world challenges actually look like. As we're wrapping up here, I want to leave you with one final and really crucial idea. All of these frontiers, all of these skills, they aren't just about being good at technology. They're the building blocks for something much, much bigger. And here it is. The specific tools you use, they're always going to change. AI is going to automate more and more of the how. The most valuable, the most future-proof engineer is going to be the one who can spot the right problems, see a real need in the world, and have the vision to decide what needs to be built in the first place. So, I'll leave you with this question. Technology is giving us this incredible, unprecedented power to create, to solve, and to build. The future of your career isn't really about how you'll do the work. It's about the purpose you give to that work. So, what problems will you choose to solve? That's the question that will truly define your next 30 years.